Hi guys, you have spoken, I have heard, you want Linux videos. So here's the first one. This is the bare bones server that I did for Windows, and now I'm going to do it with a Linux theme on it. So if you're interested in that, then keep watching this video. There's another video as well where I actually install Ubuntu Linux, and that's in another video which I've linked in the show notes below. As always, the code for this is in the show notes below. So without further ado, let's get cracking after the fade. In the last video, I got as far as installing Linux and installing code blocks. So I'm now going to use code blocks, if I can find it again, code blocks, to create the application that we want to do, which is our bare bones server. Now, again, I have not used this IDE, so I'm not entirely um, au fait. It's a word, borrowed word, but I don't really know my way around it, so I might be stumbling a bit, so I apologize for that in advance. But what I'm going to do is I'm going to go up to here and do File, New Project, and then I'm going to choose Console Application because it's a console application. I'm going to click on Go, and then I'm going to walk through the wizard. So I want to create a C++ application. I'm going to call it Bare Bones TCP Server. And I'm just going to call this bare bones TCP, and then this is going to be bare bones TCP, and the project file name is going to be bare bones TCP. Now the reason why it's going to be bare bones TCP server, let's change it to server, is because I want to be able to type this in, and if I put in spaces then it becomes a little bit more complicated under Linux, so I just want to keep this as simple as possible. So I'm going to make everything all smushed together. So it's BB TCP server. So I'm going to click on next, and I want to use the GNU C GCC compiler, and then click on finish, and that should create a base project for me, which has a single main.cpp file inside there, which is all that we actually need. So that's all we need to do to get that to work. So I want to make this a little bit bigger so that people can see it. Okay, now seeing as how we don't have any more than this one file, I'm just going to move everything across to here as much as I can. So hopefully everybody can, excuse me, everyone can see that. Now obviously we don't need hello world. We do need iostream because we want to use cout, but this is going to match up with our previous one. So what we're going to do is we're going to do create a socket, bind the socket to a IP and port. We are then going to listen, mark the socket for listening in, and then we want to accept a call, close the listening socket, socket, while receiving display message, echo message. So we want to display the message, we want to echo the message, and then we want to close the socket, and that's it. That's all we need to do. So there's a few bits and pieces that we don't need to have here. Just one second. Don't have anything else on here. So if I do terminal, so the nice thing is that what we can do is we can use the Linux manual pages. So if you go down to terminal and you type in man socket, it will give you the list of the include files that you need for each of these commands. So you can see that this is the include files we need, and then this is the format that we need. Now, if you've been doing this in Windows, you'll notice that there is something slightly different, which is it returns an integer. Now, a socket in Windows is just an integer, but we need to use integers here because we're using Linux. So just a sort of FYI for those of you who are watching this as well as the previous Windows one. We can do this for anything. So you can do man get name info, for example, which is another function we're going to use, and you can see that it's needed inside. You need to include socket h and netdb.h in there. So you'll see these header files that you've probably never seen before, but that's the reason why they're in there. We also need to include string.h as well, because if you do man mem set, you'll see that we have to include string.h in there. So just press Q as well to quit these things. So super helpful when you're developing any Linux or Unix. This even works on the Mac as well. So if you're doing anything in Unix or Linux, then it's a really handy place to get instant help. You don't need to go to a website. You just need to use the terminal. Use the man command, which is short for manual, and it displays the information from the manual. Perfect. Okay, so if we go back to here, I'm just going to write out what we need to do, and then I'm going to come back and I'm going to add the include files at the top. Or should I just include the include? Let's just include the include files here. So we're going to need include sys types.h, and you can see that it pops up as well, so it's got IntelliSense in here as well. Well, it's not obviously not IntelliSense because, you know, that's, I can't spell. Unity standard, that's the one. Include sys socket, oh dear. Sys socket.h include netdb.h include ARPA internet include string.h and include string as well. So anything that says .h is a C library, or a C has got a bunch of C functions inside there and defines all that kind of stuff. Anything without the .h is a C++. Okay, so now we have that. What we need to do is we need to go ahead and create our listening socket. So our listening socket is created using the socket function. So we do int listening equals socket. Then we need to tell it the address family, which in this case is called domain. We need to tell it what type of socket, which is our socket stream, and then the protocol. So we're just going to put 0 and then let the software, the networking stack figure it out itself. It's going to come back and say socket stream. There you go, inet. You notice there's an inet 6 as well. We want inet, which is the IP version 4 protocol. We don't want to use IP version 6 for this. Sock stream and then 0. Okay, so that is our listening socket. That's all we need to do there, but we should probably check to see if it exists. So if we want to say if listening is less than or equal to 0, actually I think it just equals -1, something bad happened. So we're going to do cr create socket, and then we do return -1. So we can't create a socket, we want to X out as quickly as possible. Okay, so the next thing is we want to take our socket and we want to bind that to an IP address and a port number. Now, what we're going to do is we're actually going to bind it to any available IP address. So I don't know what the IP address is of that. I could find out, but I really don't want to know. I just want to bind it to any number. for me, any network card running on this machine, I just pick one and then bind it to the particular port. Now our port is going to be 54,000. It may vary depending on your system, but I'm going to stick with 54,000. If 54,000 doesn't work for you, try 54,001, 2, 3, 4, 5, and so on. So I want to use socket address, and then I want to choose IN because that's our Internet Protocol version 4. Again, you can see there's an INET 6 there. We want to choose that one. And we generally call these things hints. So this is going to be our hint for the server side. So this is our bare bones server here. So then we can do hint.syn family equals AF INET. This is where your classes come in handy because like you really want to have like a separate class for this. This is obviously we're just doing this as a bare bones. Let's see how things go. Then we want to do hint.syn and then the port number. Now the port number is 54,000, but we can't do 54,000 because everything is stored as big endian. And I know for a fact that this is a little endian computer because it's an Intel processor, and Intel processors tend to be little endian. In fact, I don't know any Intel processor that isn't little endian. Now, little endian and big endian is just how we store numbers larger than 255 in a computer. And what that means is that if we have a number larger than 255, it takes up 2 or 4 or 8 bytes, depending on the size of the whole number, the integer. Now, to convert it across from a whole number that this machine understands to what the network understands, we use HTONs, which is HTONS. And HTONs stands for Host to Network Short. So it should hover over. It's not hovering over there at all, is it? Yeah, there you go. So you can see there that it takes in the host short and it converts it to the network short. So that means that it's going to flip those bits depending on whatever machine it is, whatever you compile it at this point in time. So this is going to do a translation to flip those bits in there. And so we don't need to worry about it, but we just need to remember that anytime we interact with the port number, then we need to make sure that we flip those bits across. So HTONs is super important. Don't do things yourself, do it the other way around. There's also network to host short as well, which does the reverse of that. And I think we get to see it later on, but anyway. And now what we want to do is we want to say we want to run on any IP address on this machine. So I'm going to do hint dot actually, I'm not going to do that. I'm going to use inet piton. Inet piton is this is explaining what these crazy functions do. Inet piton is an internet command, which is why it says inet, and it is a pointer to a string to a number. So it converts a number to an array of integers. Now, a network address is like 127.0.0.1, which is our home address. Okay, so that's the network address of your card, the local loopback address, the local host. Now, that takes in 1, 2, 3, 4 numbers, each separated with a dot, just so that we know what those numbers mean. Now, in order to convert that string, we pass it through this hton inet piton function. So we do inet piton, and then we specify the format of our address. So it's going to be if inet because it's version 4. The character array, which is basically a string. And to get any address, we just do 0.0.0.0, and that's any address. And then we pass in the buffer. Now the buffer is a pointer. And so the buffer we want to point to is hint.syn address. Okay. And so that is our binding information. Now that's as we've just done the binding information. What we want to do is we want to make sure that that binding information is bound to the socket, because our socket is just a number that we use internally to represent this connection, this endpoint. And so what we do is we use our bind command. Now I'm going to do this all in a oneer. You don't have to do this, but I'm going to do it all in a oneer because I want to make sure that the bind command works. So I'm going to say if bind, and then I'm going to pass in AF inet because it's version 4 of the internet. I want to pass in the address of it. So I specify the address of hint, and then I pass in the length of it. So I'm going to pass in size of hint. And then I'm going to say if that equals -1, sir can't bind to IP port -1. Actually, let's make that -2, and then we'll know. Okay, so that's us binding there. So we have our hint, and then we bind the hint to the port. Now we need to also specify the listening port in here, which I've missed out. So you see here it says _FD. FD means the file descriptor, which in Unix or Unix-like systems is the port, is the socket number. So that's why we have that there. So we have our socket there. So we say bind this socket using this format to this hint structure, and then if that doesn't work, then we bail out early. Okay. Now listening is a little bit easy because we just need to again wrap it inside the if statement there, but we want to mark the port as, we want to mark the socket as being able to listen in on. So we're going to say if listen, and then we specify the port number, which is, or the socket again, sorry, which is our listening, and then we need to tell it how many connections we need to have. So I'm just going to do so max con, which is our maximum number of connections, which in this case is 128, but depending on the operating system and that kind of stuff, it could be more or less, whatever. So we're going to say if that equals -1, we're going to say sir can't listen, and we'll do return -3. Okay. And that's all we need to do for listening. So what do we have so far? We have our creation of a socket, we have binding the socket to the IP address, and then finally down here we have our socket for listening in on, and that's it. Okay. So to accept the call, what we're going to do is we're going to display some connection information about the client, and or should we do that? It seems rather yeah, okay. Let's do that. Okay. So for this one, what we're going to do is we're going to have socket address in, and this is going to be the client. Soclen t client size. We also need char host max host chat char service max service. So you can see that max host should be about 256, which is not coming up. There you go, 1025 is the max host because you've got the 0 at the end, and then max service is 32. So that's just the service name, or these are the buffers that we're going to put those the host and service name in. What else do we need? I think that's it. Yeah, let's do equals size of client for that one. Okay, now then we want to do is we want to accept an incoming connection. So I want to say int client socket equals accept, and then we want to accept on the listening socket. We want to then pass in the address of our client. Actually, I think I made a mistake earlier on as well. Hang on a sec. Yeah, that's got to be sock address. Yeah, I need to cast it to this socket address because the binding, if I go over binding, oops. Yeah, so if I go back to here and I do and bind, yeah, you see it takes in a pointer to a socket address. Now we don't have a socket address here. We have a socket address underscore in, which is kind of similar to it, but not exactly the same. So it's going to balk at it. It's not going to like it. So we need to cast it to that pointer there. And similarly, we need to do the same thing down here. So we need to do socket address and then pass in client. We need to pass in the address of that size. So we do client size. Actually, I'll move this onto multiple lines so we can see these things. And then the last one here is, what does it take? Let's go back to here and accept. Easier doing it this way. That's not right. Run around here. And accept, and then so it takes in the address there, socket length, and then it takes in, I think that's it. It just takes in 1, 2, 3. It takes in 3 parameters. I think that's right. Yeah, just takes in 3 parameters. Okay. And I'm going to say if client socket equals -1, so if there's an error, and I'm going to do C error, problem with client connecting. Return -4. Are we up to -4 just now? -4, yeah. Otherwise, if all of that went through, then we're going to close off the socket and we're going to read in the values there. So we're going to do close and then listening. So we're going to close our listening socket there. And then what we want to do is we actually want to get values into our host and service, but really we should clean it up because we don't know what garbage, I mean, who knows where this memory came from before. So the easiest way to clean things up is we're going to use memset. So we're going to say mem set, and then it's going to be host, and then we want to fill it with zeros, and then it's going to be ni max host, and then mem set service, what did I call it? SVC, there you go. Ni max service. Okay, now comes the interesting thing. So I've been looking at my notes, which is why I keep looking down here. So for our notes here, I want to see if I can get the name of the computer, and if I can, I want to display that. So I'm going to say int result equals get name info, and that is going to be the address of the socket. So that's going to be sock address client, the size of the client, size of client, the host, which is going to be host, and then that's going to be ni max host. Then it's going to be the service, so that's going to be svc ni max service, and then the flags are going to be 0. Now, if that fails, I'm going to get a 0 back from it. And if that's the case, what I'm going to do is I'm going to cheat. I'm going to copy some things out. So I'm going to say if result. So if I got a good result, I'm going to say cout host connected on, and then I'm going to convert it back service endline. Otherwise, I'm going to inet ptop ntop. So inet ntop is the opposite of inet ntoa. So we used that earlier on. Up here, inet pton. So what we want to do now is we want to use inet n2p, which is our numeric array to a string. So luckily we have a place to put the string, which is going to be our host. We're just going to use that. So we need to specify the family again, which is if I cannot type inet. And then there is going to be the location of where the address is. So that's going to be client.syn address. Then we're going to put in where we want it to go. So that's going to be our host. And then the maximum size of the buffer is going to be ni max host. Max host. Then we're going to do cout host connect on. And now we need to do our opposite. So we want to do network to host short, and then specify client.syn port. I really cannot type today. I can't type most days, to be honest. Endline. So that's what we want to do. So if it works and we get the name of the host, all good. We can just say the host name, in my case it's Firefly, connected on service, whatever the name of the service is. Otherwise, we have an issue and we're going to have to do things manually. So this is a nice way to sort of make things look. So we've done the closing listing socket, so we can put that up to here. So there's that. Okay. Now, just move on to the next page of my notes. Okay. So we need to be able to receive into this buffer here. So we're going to do char buffer, and we're going to make it 4096. Okay. And while it's true, we're going to keep looping around, and the first thing we're going to do is clear the buffer. So clear the buffer from anything that was in there before, wait for a message, display message, resend message. That's it. Okay. So clear the buffer. So again, we're going to do memset, and then we specify the location. So it's going to be buffer. We want to fill it with zeros, and it's going to be 4096 because it's 4096 characters up there. So wait for message. So we're going to do int bytes received equals receive, RECV. Now we specify the socket. Now the socket is no longer the listening socket. We actually have a socket number here. We've got a new one, and it's up here. This is our client socket here. This is our accept here. So we're going to do client socket equals accept, and then that is our socket number now that we're going to use. So we're going to receive in on that. So we're going to say receive. So file descriptor is going to be client socket. The buffer is obviously buffer. The size of the buffer is 4096, and then 0 for the flags. We don't need anything in there. So I want to say if bytes received equals -1. Sierra, there was a connection issue. Endline break. So we're going to break out of there, and we're going to say if bytes received equals 0. This is normal. The client disconnected. Break. Otherwise, what we want to do is we want to display what the client sent. So we're going to do cout received string, and then we're going to specify the buffer, the start position, and the number of bytes received. End line. Okay. And then we want to echo that back out again. And to echo it back out again, all we do is we do send, and then we specify the descriptor. So this is going to be the connection between the client, which that's going to be client socket, and then the buffer, and then bytes received +1, because remember we need to have a 0 at the end there, and then 0 there. So that's our display message, and that is our resend message. Okay, we're almost done. The last thing we need to do is close the socket. So we do close, and this is going to be client socket. And that's it. So what, 110 lines of code, including comments. And that's all we need to do. So what I'm going to do is I'm going to click build, see if we get any errors. Where's that build log? Doesn't like that. Why is it not like build messages? Not getting anything in build messages. Build. Will it run? No. Build failed. Why is it failed? I mean, it would be nice if it was like a. Let's do a clean. Yeah. Build. Am I missing something? Am I not seeing it, or what is it I'm missing? Let me just bring this back up again. Toggle. I don't. Okay, I mean, I know there's a red line there, but I don't see what the issue is. Let me see. So I've got bind on the sockets that equals -1. Size of hint. Okay, I mean, I think that looks okay. Let me shut that down and then see. Sure. Let me see if that works a little bit better. Bring it back up again. What? Well, that's, huh? What? Okay, that's a bit of a problem. Recent projects. Oh, that doesn't have a name on it. That's why. Well, that's no good. CD source, CD TCP. That's probably why I can't build. CD BB TCP. CD BB TCP. So let me do rename. It's move, isn't it? BB TCP server to BB TCP server dot the BCP. What was that on? CBP. Okay, so that's CBP. So we can do file, open, and then we go into source, TCP, that one there, open. I don't know how to open this now. Import project, recent projects. Open. Code blocks project files. There you go. Okay. Well, that was painful. Got there in the end though. All right, let's see if this builds. Okay, there we go. We're getting builds now. All right, that's fine. Okay. So it doesn't like that from int to socket address. Why is it not like that? Oh, that's why. Size of. So you can fix that one. So there's that one there. Service is not declared in the scope. That's because it's SVC. And so the rest is on line 28. So if I rebuild again, maybe that'll just go. Nah, it won't. So it doesn't like that. So that's why. Okay. There we go. I didn't read that properly. Okay, so I want to bind this socket to this hint structure. That's why that's not working. Okay, so if I build this, okay, that's good. So let's try and run it and then see what happens. So I'm going to run this here, and so this is it running up here. I'm now going to go to a terminal, and I'm going to do cd tilde, and that's going to take me home. Then I'm going to do telnet localhost 54 like that, and that should connect to our server up here. There we go. So it says 127.0.0.1 connected on whatever that is. And then if I type in hello, this is a message. And it says received, this is a message, and it echoes it back to me. This is pretty cool, eh? So that's it. That's networking with C++ in Linux. Okay, well, it wouldn't be a video of mine if there wasn't a screw up near the end, or in the middle, or at the start, or pretty much anywhere in the video. So hopefully you enjoyed that video. If you did, thumbs up. If you didn't, then thumbs down. Don't forget to subscribe if you haven't already, and link the video, share with your friends, all that kind of stuff. That helps the channel more than subscribing, believe it or not. And yeah, enjoy the content. It's all free. It's all up there. There may be the odd advert or two, but you don't pay for it, which is the best kind of information. Information should be free. Even if Cory Doctorow doesn't want it to be free or says it couldn't be free. Anyway, I haven't read the book yet. Okay, so there we have it. That is a bare bones TCP server using Ubuntu Linux. And if you followed the previous video for this one, it's pretty much taken me, up and running from having no server to having no machine to having a machine. It's taken me less than 2 hours to get there. So building the whole thing and installing everything. So it's been a fairly fast process. I am impressed, I have to say. So this is the first one in the first video in a sort of I don't want to say series, but it's going to be I'll do like one every other week. I'm not going to do one every week for this, so you'll have to wait a couple of weeks for the follow-up, which is the bare bones client version of this, and then of course I get the UDP version as well of this. Anyway, you know what I mean. It's following the same stuff as the Windows one. So anyway, thank you all for watching. Oh yeah, you can also follow me on Twitter. I'm at Codehoose, CODEHOOSE for Codehoose. And so yeah, enjoy the rest of your day, evening, whatever you got planned, Netflix and chill. And I will catch you in the next video. Thank you again for watching. Bye bye.